Now, this time, for real, this is, like, I'm not kidding around anymore. This time, can you hear the words that are coming out of my mouth? Like, do you understand? Do we have video? Do we have audio? AOS, 5x5. I swear I know what I'm doing. Like, everybody's responding that we do have signal.
Oh, yay.
Okay, you can hear what we're saying. Can you hear what our guest is saying?
Hello.
Laurie, say hello to everybody.
Hi, everybody.
All right, can we hear what Laurie's saying? Is the video okay? Like, is everything... The joke was we get better pictures back from other planets than we get here in New York City.
Well...
Like, what are you going to do, right? It looks like everything's okay. People say we're perfect now. Show them our solution. Chat, we literally plugged into the wall. Like, we plugged it into the wall, and we have a long cable that comes from where our setup is going to be for the presentation that Laurie's going to be giving shortly, and it's plugged into Ouroboros's hip right now so that we can continue on with the stream. Laurie, thank you so much for joining us.
Thanks for having me.
I think it's actually working now.
Good.
So we can go ahead with the interview. It's like, get the people from JPL on. That's when it doesn't work. We walked all over the superstructure of the carrier, the island of the carrier, in and out of little hatches and ladders. Signal was fine the entire time. We come into this big canvas building and we can't get a cell phone reception. Anyways, she's like, all right.
Oh, well.
So, Laurie, you're with NASA JPL. How do we introduce
Yes.
what you do? Like,
Well, I'm a research scientist at NASA JPL. I'm
Okay.
an astrobiologist, which means I look for life elsewhere and also how life started here.
Okay.
And I work on the Mars Reconnaissance Orbiter mission.
so what does that mean? You look how life started, right?
Yeah.
Does that mean you're like looking at data coming back from other places? Are you doing experiments here to try and figure out what we can look for?
More the second one. So
Okay.
we want to understand, if you look for life elsewhere, you have to sort of know how it could get started in the first place. Because what if a planet is, able to support life, but not actually able to start life?
Okay.
So you might see a place that seems like you could put life there and it wouldn't die.
Yeah.
But that doesn't mean there is life there. Because what if it never started?
Wait, so are the conditions like that different? Like the conditions
Yes.
for I'm going to use genesis. It's like a $5 word. The genesis of life versus the supporting of life or whatever.
They are. Actually, we call that habitability, is
Okay.
when life can live somewhere. But if you think about it, life can live everywhere, basically, on Earth. Like we find it, in ice, on salts, in the deserts, everywhere.
Right.
But life did not start everywhere. So there are
Okay.
certain conditions that you need for the origin of life.
To, like,
and,
kickstart life or
yeah,
whatever.
to kickstart it. But then once life diversifies, it can do anything.
And then it
So-
can sort of adapt to different...
It can adapt to all sorts of things. Life right now is so diverse and amazing.
I'm out of my element here. Like, I like space and science, but I don't really know much about what you do, right? So when you talk about life can start in different places, does that mean like what do you need for life to start?
Well, that's the question that we work on, is what do you actually need? Because some stuff you think it's useful, it might help, but could you have something else instead
Right.
that wasn't on Earth maybe? And so there's a few different types of environments that we look at. I tend to focus on the deep sea, so the hydrothermal vents at the seafloor.
Okay.
Other people talk about things like volcanic pools on the surface, or things like wet and dry cycling and whatnot. So there's a lot of different ideas right now.
Right.
But figuring out really what the conditions are is the important thing, because what if you had the same condition in multiple types of places?
Gotcha.
So that's kind of what you have to think about, is what are the conditions, and then where could you find those?
Right. So you say conditions. Like, what does that mean? Like certain temperatures, certain elements available? Like, what does that mean?
Kind of all the above. Like, what temperature do you need? What's too hot? What's too cold?
Right.
What elements and ingredients do you need? What energy do you need?
Energy, okay.
What processes? Like, do you have to heat it up? Do you have to dry it out? Do you have to just have it be there where it can access a lot of different things at the same time, and so on? And then you have to think that there's different ways that might happen on a planet, because all
Right.
planets are very different.
That's crazy, because I think, I guess in the time spans that life might come about, are you like making life in the lab?
Well, we'd like to.
Question, right?
It's not easy.
You're not like,
So-
you have like a test tube and you put the conditions just right and then magically there's life that Laurie's created.
That would be great. Everyone would like that to happen in their lab, but actually no one has done that yet.
Right.
Because it's very, very difficult to find out exactly what those conditions are.
So is that what you're trying to do?
Yes, we would like to. And so the origin of life is very complex, and it goes on, there's a whole bunch of processes that you have to do. So usually researchers tend to simulate a piece of it only, because you could
Okay.
it's too much work for one person or one group.
Right.
So my group looks at how do you get the most fundamental organic molecules, like amino acids and things, just from a geological setting.
Right.
No stuff that came in, say, from a meteorite or something. Like, could you actually make it just from what's in the ocean?
Ah, I gotcha.
Because if so, then maybe you could have it on Europa or Enceladus.
So make it from the ocean before there's life life in the ocean,
Yeah,
right? Did I get that
exactly.
right?
Yes.
So you have like these basic conditions, and there's no life, there's no fish swimming around, algae, whatever, right?
Right.
And with those basic building blocks, if you heat it up, cool it down, dry it out, whatever, mix it around or whatever, can life start from that?
Maybe. That's what we'd like to see.
Maybe. I like
maybe.
Like maybe.
You know?
It's
And I
actually
mean-
my job to find out. Like,
Yeah, we test a lot of things, and you have to be scientific about it, of course, or it's not science, right?
Right.
So it's, how do you know that one thing affects that as opposed to something else that's happening at the same time? You have to separate each one in its own experiment. And
Controlling
then,
the variables or whatever,
Controlling
right?
the
Yeah.
variables, you can only change one thing at a time. Otherwise, how do you know what caused what?
because you never know.
You never
right?
know. And then if you do one more variable, you have to do everything with that variable. So each time you add a new thing, the amount of experiments you do increases by multiples.
Right?
And at some point, it's not practical anymore. So
Okay. So
just,
wait, once it gets to not be practical, like where do you go with your research? Like, what do you do? You're like, okay, I think this is going to work, or we've observed this, or we see that Earth works this way. Like, what do we do with it?
Well, we try to understand, first of all, what was on early Earth.
Okay.
And so that is hard because we don't have a whole lot of rocks from early Earth. Earth is mostly a young planet because the seafloor is young and it's 75% ocean.
Right.
So you don't have tons of evidence, but we can look at other planets. Like Mars is very old. Its whole surface is really old. So we can
Right.
try to understand, what was early Mars like, and maybe Earth was similar. But also early Earth was really different from today. So
Right.
there's some few really crucial things that are not the same. So one of them is there was no oxygen in the atmosphere.
Wait,
Yeah.
there was no oxygen in the
Yeah.
atmosphere of Earth?
Because oxygen came from life. Yes.
Really?
Yes.
So it's almost like we
Photosynthesis.
made the Earth, or life made the Earth possible for us to be here.
Yeah, life really transformed this planet. If you went back 4 billion years, you would see a rocky ocean world, but nothing would be like it is here. You wouldn't have, say, soil or plants or even the same atmosphere.
Yeah.
You'd have different radiation hitting the surface because the atmosphere affects that, but
Right.
life changed the atmosphere.
Right?
So
So
life
it's like the
did
life
everything.
terraforms the planet to...
We did.
Could
I
we
mean,
say
not
that
we.
it makes it better? Yeah, not we, right?
The cyanobacteria terraformed the
The
planet.
cyanobacteria, nice. I don't go to family reunions and hang out with the cyanobacteria or anything like that.
But you breathe their oxygen.
So that's something I never really thought of before. Like we go out there and we play a lot of video games because we're on Twitch right now, right? And I play Elite Dangerous. And in Elite Dangerous, you sort of go out into the solar system, or go out into the universe, and you search for other planets that have life, right? Or could support life. But a planet that might support life right now isn't necessarily a planet where life would have started, just like
That's
you were
right.
saying. Because the
That's
life intrinsically changes the composition of the planet.
Right. It does. And I mean, you could imagine Earth is so diverse with its life. There's probably some bacteria you could find that if you put it on Mars in a certain place,
Right,
it
be like,
wouldn't
all right,
die. I
it's
mean,
Mars.
you could find one. That doesn't mean life started there, though.
Right.
So, I mean, we really have to understand what were the specific conditions that were required, and could you have had those? Because also Mars has changed over time. So if you go back 4 billion years, early Mars is not the same. And the same may be true for all the planets, like even Venus and Europa.
Yeah.
So how do you know what it was like 4 billion years ago? It's hard enough for the Earth.
That's a good question.
So
It's just it's crazy because I was talking about the video game and it rewards you. It's like, oh, here's a planet that can support life, and it's like, well, that might not
That
be what
sounds
you really
good.
need to look for. All right,
That's
good,
a
it can
start.
support life. Maybe if we had the technology, we could move there, but that doesn't
Yeah.
necessarily mean that life would have started on that planet.
That's
so it might
right.
be a whole other thing that, like, here's a is there a word for it?
prebiotic.
Prebiotic.
I guess
Nice.
before life started.
I know part of that, like antibiotic, prebiotic. Like
Yeah.
Those prefixes make sense to me.
Pre-life.
The prefixes make sense. Anyways.
And you could also have a planet where life started and then died out, and then the planet became a planet where life could not live. So you can have the reverse.
Really?
I mean, if you think about it, right? Like any planet could maybe start life, but then it's possible to imagine a history where
Something
like
happens.
Venus, for example. What if life started on Venus 4 billion years ago because it was very different? Now it's really hard for life to live there.
Right.
It could happen.
So a lot of this, okay, this sounds like a lot of thought experiment sort of stuff.
It is.
Right? Where we're like, what if this happens? And you take some basis of knowledge, which is, I know that these molecules act this way, or whatever, right? I don't know the right basis of knowledge. But you take what you know and you sort of applied it to, maybe this is what happens.
Yeah.
How does that help us understand the other locations we have in our solar system?
That's
Does it-
kind of what we do a lot, actually, in planetary science, is you look at things we have seen on Earth,
Right.
like a geological setting, but also like life and what it does and things we know are possible.
It's like life as we know it,
Yeah,
right?
life as we know it, which, by the way, is always changing because we didn't used to know, for example, that life doesn't need sunlight to live. We thought all life really comes from photosynthesis and it's just a food chain.
Right.
But it turns out life can actually live from chemistry from the Earth.
Right, the vents, right?
Right? So the vents, yeah.
Aha,
So that's
okay.
a big deal. It means that's another way that life could exist elsewhere that we didn't used to know about.
Gotcha. So that gives us another thing that we can look for on other planets or moons or whatever.
That's
I'm just
right.
going to use the term planet. Worlds? Do you have a generic
World
term?
is good.
Yeah,
Because
worlds.
a moon is something that goes around a planet,
Right.
but that could also have life, like Europa.
Right.
So we call it worlds.
Worlds. Worlds is a good generic term when
Yeah.
you're talking about other places that aren't here, right? So we learn some things about that we can observe on our planet, and we say, wow, all right, maybe that happens on another planet. So
Yeah.
what sort of things, have we observed vents like that on another
Well,
world?
not directly, because
directly.
there is no other ocean planet where the ocean is not either gone now or covered up with ice.
Covered up with ice, okay.
So,
Because the Earth
yeah.
has a nice liquid water ocean, and it's on the surface, you can swim in it, right?
Right.
Because we are in the, I think we said the Goldilocks zone.
Yeah.
We're not too far.
For surface water.
For surface
But
water.
you can have deep water.
Ah.
So, habitable zone is a loaded term because it mostly used to mean that the water on the surface will be liquid.
Right.
But it doesn't have to be for there to be water.
That's the whole life as we know it again. It's
Yeah.
like, well, life should be this way because that's what we think, right?
Or planets as we know them, really.
Yeah. So you can have things that we say Earth-like planets aren't
Yeah.
necessarily like planets that can support life because Earth supports life, but that doesn't mean it's the only model.
Right, it doesn't mean it's the only model, and then there's other non-Earth-like planets that might also support life, or
Right.
the origin of life.
Okay.
So you could have an ocean on, say, Enceladus, Saturn's moon, and that has a rocky seafloor, and there is evidence that there's vents there now.
Right.
We haven't seen them directly, but there's geysers going out into space,
Right.
and if you look at the composition of those, it basically says that those were formed at 90 degrees Celsius or so, which is pretty hot. That's the temperature of a vent.
So wait, you can look at the geyser that spews out into space.
Yep.
And they probably do something with a spectrum or something, right?
Yeah,
They look at
yeah.
light going through it. That's how they study lots of things, I think.
Yeah, pretty much.
And you can figure out the temperature that it formed at and the composition of it. And based on
Yeah.
those things, you can figure out.
Well, you can figure out a lot if you know the composition. So
Right.
the details of, those particles, some of them are water, some are salt, but what exact salt is it? And, even when you say it's carbonate salt, like different types of carbonates exist, and you can figure out how acidic the ocean is from that.
Right.
They actually found, these are other papers I've read, they found particles in the plume that if you reproduce the particles in the lab, they only formed at that temperature. So it's things like this, you do
That sort of
lab
thing.
work, simulating,
Yeah,
and then
okay.
you narrow it down, and you try to simulate things in lab and then relate it to what was found.
Right. It's like, it just blows me away. I can't get over the fact that life as we know it, it's like Earth, oh, here's life, right? Whatever.
Yeah.
But that doesn't necessarily mean that that's the only life that we know or the life that we
It's
start.
true. Life evolved on this planet, and it's very specific to Earth in a lot of ways. So
Right.
it's hard to know, which parts of life as we know it are because it was made here,
Right.
right?
But so wait, when you say that because life as we know it, right? You're not getting into things like, oh, this alien probably has 3 infrared eyes or whatever, right? Do you deal with mostly like bacterias, like little things? Like, how does that work? Where does that go?
We generally do, not because, it's impossible to have other types of life, but
Right.
bacteria, well, the microbes are the first.
Microbes
and
are the
so
first.
That's the origin of life.
Like there's a scale
Yeah.
of like life probably starts
It's
here, right?
evolution. You start off with prebiotic chemistry, not life, but kind of close.
Okay.
Something else happens, and then you have a cell, and cells evolve and diversify, and then you have all the rest.
Right.
So
It just sort of
yeah.
goes from there.
Understanding what was the earliest cell on Earth is another thing. So you want to know how you get to a cell, but also what was the first cell like,
Right.
because the one that you have to get to must match up with that. So it's called top down, bottom up.
Top
and they have
down,
to
bottom
match.
up. So this is even like when we say we're looking for life on other worlds or whatever. We're not looking for green aliens or anything like that.
Not really.
We're looking for really small things.
Yeah, and signs of that is hard to see from space, right?
Right.
So, I mean, if you were orbiting the Earth and you had to say, is there life on this Earth, and you can't look at humans or anything like that,
Right.
how would you know there were microbes here?
Oh, that's a good question. How would you know?
Well, what are you breathing?
Oxygen.
Because it was made by microbes.
Okay.
So that's one option.
So,
you
wait,
can do
are there
stuff like
worlds
that.
that naturally have oxygen, or
There
is
could be.
Okay.
Some people, and you have to think about, are there other ways you could have gotten the oxygen? Maybe.
Right.
And there are some theories for that. Biology is a really obvious way to get it.
Okay.
If we saw an Earth-like oxygen atmosphere, that would be very interesting.
Gotcha. Have we seen any of those?
I don't think so, but I'm not
Okay.
an exoplanet person.
Not an exoplanet
But there are
person.
so many exoplanets now
Right.
that, if we could see the spectra of those, it would be really interesting to see what they find.
So, what else sort of interesting do you do with your work? Like you said, there's a lot of laboratory experimentation, there's a lot of thinking, there's sort of, I observed this, and so I think this might be happening. Like, what other things do you do to sort of help you understand your work?
Well, aside from the lab stuff, we do some, planning for the field.
Right.
And so I'm part of a project where we're going to take a underwater laser and try to put it at a hydrothermal vent in the Pacific Ocean.
Okay.
Because the vents are always changing. There's that smoke coming out, and chimneys grow, and life lives or dies.
Right.
And so we want to watch that vent from a distance over a period of time. Because you may not always get to have samples come back from things if you're doing planetary science. So we're going to use that as kind of a test of stuff that you might one day be able to send to other worlds or even use for oceanography here.
It's like an experiment that you're trying to do that you could use in other places. So
Yeah.
you can't go up there and like scrape the side of the vent.
Yeah.
But how can you look at the vent from a distance without touching it and figure out?
Exactly. And you're not going to know everything that you would know if you had the sample, but you might know a fraction of it.
Right.
And so that's the question, is how much science return is what we call it, of the science
return,
that you
like
can get. And you know how much you can get with all your efforts. How much do you get with just this instrument?
Right. So this laser pointing at this vent, yada, yada, yada.
Yeah.
And that's like, what can you learn from that?
What can you learn from that? Is it enough? Is it
Right.
enough to tell if there's life there? If it's not enough, what else do you need?
Right.
And then, if it turns out that it is enough, that's great. And then you just have to talk about how many times do you fire the laser to know? Can you do it once a day, once a minute? How many batteries do you need for this,
whatever,
et cetera, et cetera. So
No kidding.
science operations is what that's called.
So firing a laser at a thermal vent
Yeah.
under the ocean, trying to figure out how to design sensors, experiments, probes, whatever, so that we can look for the same sort of conditions on other worlds. Did I sum that up pretty well?
Pretty much.
I've been
yeah.
paying attention,
Yeah.
kind of. She's
Yeah.
like, well, not exactly, but I'll let you get away with it.
It's a lot of projects we have.
I like the fact that every time I ask a question, you're like, maybe that's how that works.
Yeah, we never know for sure. That's the thing about astrobiology.
We have a couple minutes here, chat. So if we have any questions, I still do have my phone up. And if you have any questions for Laurie, who is can I say astrobiologist?
Yes, astrobiologist.
From NASA's JPL. She's going to be doing a presentation here. Again, we're at Intrepid Sea Air and Space Museum in New York City. We're going to be streaming the presentation as well. You can see people walking around the background, filtering in.
Cool.
I'm trying to keep up with her. I'm like barely understanding some of the things. I'm like, wait, but then, okay, I know lasers. Like I can point lasers at things. If y'all have any questions, I will read some questions here, and I will see if there's anything that TwitchCat knows. Do we know when we'll go to Europa? Is there a mission going to Europa yet?
So there's one in development that's going to fly by Europa Clipper.
Gotcha. So are there any instruments aboard Europa Clipper or potential instruments aboard Europa Clipper that are going to like help your work?
Well, I mean, all of them would help, because if you can understand
Any data, right?
how deep is the ocean, how salty is the ocean, does it actually circulate with the ice, things
Right.
like that.
Okay.
So understanding what are the fluxes in and out of energy is very important.
Gotcha. All right, that's a good question. Let's see here. Do you expect the OSIRIS-REx sample will add useful info to your field?
It could actually. So
Maybe.
maybe. But the asteroids are really interesting because this is primordial material.
Right.
So there's a lot of worlds that may have different rock composition than Earth.
Right.
Earth forms where it does because it's a certain distance from the sun and so on, and certain size. So understanding all these bodies is really useful. Could you have life on a planet that's not as big as Earth with different rocks?
Right.
So that's going to be very useful too.
No kidding. Oh, here we go. What are the fundamental requirements astrobiologists have identified for life?
Excellent question. So that's actually
I should have been reading this the entire time.
Well, this is one of the questions that we ask when teaching class and stuff, because it's very hard to define what life is.
Right.
Everyone knows it, but like you can't really define it, because a lot of the things you think of as life, you could always find a thing that's not life that has that.
Okay.
So some of the requirements are it will be composed of organics, though
Composed of
people
organics.
sometimes argue that.
As we know it.
It's usually, or as we know it, it's going to have an energy metabolism, so it's going to be actively metabolizing, which means doing redox chemistry of some kind.
Okay.
It's going to have information, so the DNA, RNA, though, you could imagine other forms of that.
Right.
And then
Some way to store and pass on
reproduction,
information. Okay.
should be able to make more cells out of the single cell and so on.
Right.
So, finding something like that would be amazing. Realistically, we're going to find pieces of this.
Pieces of that,
If you
okay.
found an RNA molecule, great. It's not life, though, is it? Because I don't know.
You're the astrobiologist, is it?
Like you can buy RNA chemicals in a bottle. It's not quite alive,
Okay.
So, but yeah, those are some of the requirements.
All right, that was a really good question.
Yes.
Let me see here. Wow. Okay. What properties are used to quantify the odds of a star harboring Earth-like life? Is that the sort of thing that you look at?
Well, yeah. This is also kind of a thought experiment. So some things that are important are the type of star, which is its age and its heat and things like that.
That talks about its energy output, right?
Right, like energy output over time and so on. You need the star to be alive for billions of years. Not all stars are.
Oh, that's right. Okay.
So you also need
Enough
the
time
planet
for
to be
life
close enough
Yeah.
and big enough and made of the right stuff. Not all stars have a lot of these metals and things that Earth is made of.
Right. Okay.
You need to have, let's see, you know, maybe other planets in the solar system too. People think sometimes that Jupiter might have been important for Earth because it maybe catches comets and things.
Like
or
flings them into
Earth's
Earth or something.
moon is very important for keeping the Earth stable.
Right.
Stuff like that.
Okay.
So it's kind of the star system as a whole is very important.
Okay. So all sorts of different things.
Yeah.
Let's see here. Oh, here we go. What existing life on Earth is best suited for life on Mars or the Martian environment?
Ooh.
Do we have anything like that?
It depends on where on Mars, but I don't know. I'm just kind of like shooting from the hip here because I don't
that's
do
fine. We're all shooting from
microbiology.
the
But
hip.
how about, say, a iron oxidizing bacteria, and if it was going to live like this, it would actually use the minerals of Mars as
Right.
its energy source.
Right.
So it could be down on the subsurface, maybe.
Right.
You know, metabolizing that with, let's say, ammonia or something.
Gotcha.
Yeah, there's various things.
Follow-up question, how could we look for life like that on Mars or another world?
That's a toughie because unless you're going to get that sample, you know, that can be very hard.
Right.
So you can do things like look for carbon in the rock.
Right.
You could look for the sign that that mineral was altered. That's one that I would prefer.
Okay.
Look for the energy produced, like in the form of voltage.
Right.
Same ways we do it on Earth, honestly.
There was, oh gosh, I'm going to mess this up. There was something, we got data back from one of the other Mars exploration missions that was like, they found the building blocks of organic molecules or something like that. Right?
Oh, yeah.
I'm going to say that because she's like, what? No, that didn't happen.
I mean, I'm not sure which exact thing this was, but there have been instances where organics were found using
Right.
the Mars rovers.
But organics
So-
doesn't mean life.
Right.
That's something that we get a lot of the time. It's like, oh, they found organics on Mars. Wow, that's amazing. And
Well,
that
this is,
doesn't mean-
origin of life is all about organic chemistry, but it's not alive yet.
right?
So I know very well, as does every origin of life scientist, you can go a long way with organics before you are alive.
Before you are alive. You can go a long way with organics before you
yeah.
are alive. I like it. Let me see here. Here's another one. What would we be able to detect signs of life from the contents of a plume? Like a plume that's ejected from a planet.
Oh, like from Enceladus or something.
Yeah, like Enceladus or something, right?
Possibly. I think it depends. It depends. So if that plume represents what's in the ocean, rather than something, say, coming out of the ice or, you know.
Oh.
But if it's actual material from the ocean that maybe has circulated up from a vent or something,
Right.
you might see remnants of cells or pieces of organics. And at the very least, you might be able to tell if there's energy for life.
Okay. Is that the sort of thing where we could look at it from a distance and try to figure out if it has life in it, or do we have to fly through it and like scrape
Probably
a
have
sample?
to grab some of it.
Scrape a sample off our windshield or
Ideally.
whatever, right? Good deal. What are we doing on time? We have about 2 more minutes left. Here's another good question. What kind of life, there's all these just out there questions, right? What kind of life could be born on Titan's ethane lakes?
Ooh.
And do we observe anything like that on Earth that we think might be able to live on Titan?
I don't know if we have observed anything on Earth,
Right.
but it doesn't mean it couldn't live there. There could just be different types of life and different types of chemistry.
Right.
So
Are there people trying to make life? I say make life like that. Like, is there somebody in a lab somewhere that has this sort of environment and they're like shooting it with radiation or heating it up or whatever, trying to see what happens?
there are actually.
Yeah.
So I mean, in the field, there's a lot of people doing different things. There's people trying to understand how life on Earth began.
Right.
Where you have to sort of aim at this target of Earth's earliest life that we kind of know what it was.
Right.
Whereas other people are trying to do artificial life, where you create something alive that's not meant to be Earth-like.
Okay.
And then you have people studying life as we don't know it, and things like Titan, and even other stuff.
Gotcha.
So there's all this stuff is going on. It's a really exciting field.
There's a lot of people thinking about this, as it turns out.
Yes.
Yeah. So this is going to be the last question.
Okay.
And I really appreciate the time. Again, this is Dr. Laurie Barge, JPL astrobiologist. Right? I can
Yep,
say it that
that's
way, right? She's spending some time doing some Q&A with us. What's the coolest, craziest, most mind-blowing, etc. thing that you've come across in your studies, your work, the sort of what you do?
Well, I mean,
throw that out
it's
there.
also awesome. It's hard to
It's
say.
also awesome. I like it. She's like, it depends.
I know. Well, let's see. I mean, it's kind of simple and nerdy, but I just really enjoy when we do stuff in the lab and we learn something new based on stuff that we did. So I find this very satisfying. It's one of the most fulfilling parts. So we have these glove boxes that are full of not oxygen. We fill them up with nitrogen and argon. So you can make early Earth in a box.
Right.
And you can maybe do Mars in a box. And so we do reactions in there, and you get to see these minerals and rocks that we made.
Right.
That are, you could not bring them outside the box. They'll ruin themselves.
They would ruin them. They
But
couldn't
you
exist
can
in
see
Earth's
them in
atmosphere.
there. And so it's cool. It's like I get to see a time machine of what Earth could have been like in some sense.
That's really cool. Chat. What I want y'all to do is say thank you to Laurie. Laurie, thank you so much for the time here.
Thank you.
We're not done. We're going to get to watch Laurie's presentation. What's the title of the presentation?
Oceans on Earth and in the solar system.
We look at the projector over there. Oceans on Earth and in the solar system.
Yes.
And we still have about 45 minutes, another hour here where Laurie's going to be doing the presentation. We got some slides and stuff like that. We're not done with this, but Laurie, thank you so much for the time.
Thank you.
We appreciate it, and we're just going to awkwardly follow you over there.
All right.
You can go get set up for the presentation. C-Cup, can you get her microphone? And we will
Sounds good.
watch your presentation. Thank you, Laurie.
Excellent.
All right. Yeah, chat. I've done a lot of interviews, and I was like trying to keep up there. It's like, wait, like trying to wrap my head around. Wait a second. A planet where life can start is not necessarily a planet where life can exist, or a planet where life can exist isn't necessarily a planet where life can start, and that sort of things. I mean, we were all over the map. It looks like our technical difficulties were resolved that time, right? Or we're good to go on the technical difficulties there. Yeah, you did a really good job. I was, I was frantically treading water, trying to be like, wait, what? Hang on a second. I got to talk about Elite Dangerous for a second. But I wonder, like, we always go out there, and I guess in Elite, the reason that the Earth-like planets are worth the most is because they're places that we can colonize, right? But if you're trying to find like primordial worlds that might start life in all sorts of different formats, just not as we know it, like Goldilocks zone, water, surface, liquid, surface water, I guess is the right way to say it. There may be all sorts of ways that life can start. There may be all sorts of planets that can support life. It may not need to have oceans on the surface. It may have ice on the surface with oceans underneath. It may not need photosynthesis. It may get its energy from somewhere else, chemical reactions or geothermal energy or something like that, heat happening from the bottom of the planet. That was really cool. And I am excited because in just about 8 more minutes, we're going to have the rest of the presentation. So here's what, or the rest of the presentation, the actual presentation. Here's what we're going to need to do. We are going to step over right quick, and we are going to get set up. I'm going to go to the Be Right Back screen. Again, we're at Intrepid Sea and Space Museum. We're in New York City. It's one of their astronomy nights. They have 2 scientists, or a scientist and an engineer from NASA's JPL. We're going to be watching their presentation here shortly. This stuff is possible because of y'all. I appreciate you. We're out here on a virtual field trip supported through Vectors. Vectors is a 501c3 educational nonprofit. When you donate to Vectors, which is the next thing you're going to see, that supports us to come out here and bring this sort of content to Twitch. I know I'm not here playing video games. I know I'm not like, what are we doing these days, Apexing or whatever, but I do hope that you appreciate this stuff. This stuff is the sort of content you like to see on Twitch. So when you get this scene, this is going to be a list of people who help make this and other events like it possible. We're going to go get set up to get the presentation going, and we will be right back. Give us about 4 or 5 minutes here. I appreciate you, chat. I appreciate you. 3, 4, 5, 6, 7.